Okay, so today's lesson 5-4, the binomial theorem, and this is part 1 of a 2-part lesson. So today we're going to learn how to solve a binomial to any power using Pascal's triangle. So Pascal's triangle is a pattern of numbers discovered way back in the 13th century. The pattern can be used to determine the coefficients of an expanded binomial. So a binomial, 2 terms, and raised to any power. So the pattern goes, the first term in the Pascal's triangle is 1. And then it breaks down ones all along the outside of the triangle on both sides. And then you add the 2 terms together to get the next term. So the 1 plus 1 makes a 2 in the middle. The 1 plus 2 makes a 3. The 2 plus 1 makes a 3. And this pattern continues. So we do here 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 4 is, or 3 plus 1 is 4. And then if continue, we got 1 plus 4 is 5, 4 plus 6 is 10, and so forth. And that's how the triangles form. So if you wanted to make any row, you could just add up the sums. It always starts with a 1, and then you add the sums of the 2 numbers to get the next row. In the resources for today, you're going to see that there's a Pascal's triangle for you to use that goes up until the 16th row. So this one only goes to row 5. So how Pascal's triangle is used to solve a binomial is you take the row number that has the binomial exponent as a second number. So this is the 5a to the 5th. And what you do is you take these numbers here and make them the coefficients. So 1, 5, 10, 10, 5, 1. And then your first term of your binomial starts to the 5th degree and works down all the way down to the 0 degree. And your second term starts at 0 and works its way up to the 5th degree. So we're going to work this and see how we can find the expansion of a binomial. So instead of taking a plus 5, multiplying it by a plus 5, getting that product, and then multiplying it by a plus 5 again, or a plus b, sorry, I don't know why I was saying 5. And then taking that product and multiplying it by a plus b again, and then taking that product and multiplying it by a plus b again, you can do this shortcut method and get the answer. So in binomial expansion, a plus b to the nth power, there are n plus 1 terms. So the number of terms is always 1 greater than the exponent. N is the exponent of the a in the first term and b in the last term. In successive terms, the exponents decrease for a by 1 and increase by 1 for b. The sum of the exponents in each term is the same as whatever n was, and the coefficients will be symmetric. So let's look at this one, a plus b to the 7th. So if you go to the 7th row, you're going to look at your reference sheet, like I said. So the reference sheet looks like this, and we're going to pick up the 7th row, which means the 7 is a second number here. And we're going to write across our paper, leave space in between, 1, 7, 21, 35, 35, 21, 7, and 1. Notice the pattern, it's symmetrical. Okay, once we copy the row down, we're going to take our A, and it's going to start at the 7th, and then it's going to go to the 6th, and then to the 5th, and then to the 4th, and then to the 3rd, 2nd, 1st, and the last one is a to the 0, which is 1, so we don't need to write that one. Then b does the reverse. It starts at b to the 0, so we don't need to write that, and then goes b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, b to the 5th, b to the 6th, and then ends in b to the 7th. And then you're going to simplify these terms. It's always plus signs between, unless there's a different sign. So right now this is all positive, so it's going to be plus. All positive plus, 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 and plus. And if we look, the a goes 7, 6, 5, 4, 3, 2, 1, 0, which tells you a is the exponent in the first term, and b in the last term is 7. And then they go down for a and up for b. The sum of the exponents in each term, so this is 7, 6 plus 1 is 7, 5 plus 2 is 7, 4 plus 3 is 7, 3 plus 4 is 7, 2 plus 5 is 7, 1 plus 6 is 7, and then 7. So the sum of the exponents will always equal 7. So that's expanded binomial for A. So now let's look at the next page. B, we're going to expand this one. So this is 4. So we're going to go to our table here. and we're going to copy down the 4. So we look for the 4 as a second number, and we copy down 1, 4, 6, 4, 1 across our paper. And always just leave a lot of space because it makes it easier. So we take our a term, which is a first term. In this case, it's 3x, and we start with 3x to the, because it's 4, to the 4th. And then we go to 3x to the 3rd, and then 3x to the 2nd, 3x to the 1st, and then the 0 we don't need to write. And then we go to our second term, which is positive 2. And we start with 2 to the 0, which is just 1, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, and 2 to the 4th. It's important to make sure you use the parentheses. So then we're going to simplify each term. Because everything's positive, they're going to have plus signs in between them. Make sure you use order of operations within each term. So this is 1 times 3 to the 4th. 3x to the 4th is 3 to the 4th, which is 81, x to the 4th. And then we bring down our plus sign. If we go to this term, exponents first. So 3 times 3, 3 to the 3rd is 27. And then we're going to take the 27 and we're going to multiply it by 4 and by 2, which gives us a total of 216. And then we have the x to the 3rd. And then we go to the next term. In this one, we would have to do exponents first. So 3 squared is 9, 2 squared is 4. So really we have 9x squared and 4. And we're going to multiply those by 6. And that gives us a product of 216 again. And it's x to the 2nd. And then we go to the next term. This is 4. The 3x would stay the same because it's the 1st. 2 to the 3rd is 8. So 4 times 3 times 8 is 96. And there's just x to the 1st. And then we have 2 to the 4th, which is 16. And then this is your expanded binomial. So we'll look at one more to make sure you see the pattern. The next one is 4 again, so it's going to use the same numbers. 1, 4, 6, 4, 1. And again, we're going to start with the 2x to the 4th, and then 2x to the 3rd, 2x to the 2nd, 2x to the 1st, and then 2x to the 0. And then that negative sign is part of the value. So negative 3, oh, sorry, this is the 0 one, so we don't need to write it. Negative 3y to the 0. And then we have negative 3y to the 1st, negative 3y to the 2nd, negative 3y to the 3rd, and negative 3y to the 4th. So now we're going to put plus signs between each term. And we're going to simplify the first one. 2x to the 4th would be 16x to the 4th. Plus 4 times 2 to the 3rd is 8x to the 3rd times negative 3y. If we multiply that out, we're going to get negative 96. So it's not going to be plus because we're doing times a negative. So negative 96 x to the 3rd y. So that takes care of that term. Now we go here. If we simplify this, we get 2x squared is 4x squared. Negative 3y squared become 9y squared. If we multiply all that together, we get 216x squared y squared. Then we go to the next term. 4 stays the same. 2x would be the same. Negative 3 to the 3rd is negative 27y to the 3rd. And if we multiply that together, we get, sorry, it's going to be negative again. Negative 216xy to the 3rd. And then our last one is negative 3 to the 4th would be positive 81y to the 4th. Okay, and if we check, as you can see, x goes 4, 3, 2, 1, 0. Y goes 0, 1, 2, 3, 4 for the exponents. And if we add these up, this is a total of 4. This is a total of 4, 4, 4, and 4. So that is how you expand a binomial. Be really careful with order of operations, with working your exponents and watching the signs. If there is a negative sign, it's going to make every other sign negative. So be really careful with watching that.